Okay, so in the last video we introduced the idea of a scatter plot and drawing a scatter plot. Now I've used the example here that we used in the previous video when we graphed up these points on our scatter plot. Now what I want to do from here is just make a couple of observations about what we kind of see here. Now just some initial things is we can see basically as my height is getting bigger, as my height's increasing, my arm span is increasing as well. So I'm just going to write that down. So arm span increases as height increases. Okay, that's one thing. And another thing we can see is that the dots on our scatter plot appear really packed in. What I mean by that is if we were to think of how scattered they are, they're actually not too scattered. In fact, when we sort of highlight them as we've done now, if I go through like this, we can see it forms a line. Now, what I'm going to write here is that the dots form a line. Now, what does this line tell us? Well, the more packed in these points are, the more they form a line, the more we can say that there is a relationship here. Because we can clearly see that as my height's going up, my arm span is going up. And these points are telling me that because they're forming a line. Now that is going to be the basis of the ideas that we're going to be introducing in this particular video. Now what we're talking about here is what's called an association. Now an association means a type of relationship. So an association exists between two variables. So for example here, height and arm span. If the scatter plot follows a linear or curved pattern. Now we're not really going to talk too much about curved patterns in this series. We are going to be talking about linear patterns. So the more linear these are, the more we can say there is a clear association between them. Now, a couple of things we're also going to talk about is direction. Now, I pointed out here that as the height increases, the arm span increases. So this is what we call a positive direction. So positive direction means as one variable goes up, the other goes up. Now, this is reminiscent to what we did way back in linear relationships when we talked about gradient. A positive gradient meant that one variable increases as the other increases. So that's a way you can remember this as well. We can relate this to the gradient. Now, just like with the positive gradient, a negative gradient meant that as my x variable gets bigger, my y variable gets smaller. So if we look from left to right, this is going in a downward direction. So in the same way, this relates to our gradient for a line with that is negative. So as one goes up, the other goes down. So this directionality with lines that we talked about applies to scatter plots as well. So the association with the scatter plot that we did is going to be what we call a positive association. As one variable gets bigger, the other gets bigger also. Next thing, we are going to introduce what is called the strength of an association. This measures, for lack of a better phrase, how much scatter there is in the scatter plot. Now, what we mean by this is basically how linear is my scatter plot. Now, when we have a strong association, this means that there is not a lot of scatter. We can see our points here are really packed in with a very clear line. And there's not too much of a gap in between these. They don't increase out. They are packed in a really small line. When we look at this one, however, we can see that the dots are starting to get wider. There's still a line there, but it's less clear that it's a line because the points are a lot wider. It's not as packed in as our first example over here. Now, finally, a weak association means that it just continues to get even wider. There's even less of a relationship between my two variables. So here we can kind of still see that as one's getting bigger, the other's getting bigger, but it's way harder to tell because the points on my scatter plot are a lot further apart. Now, the more these are separated, say something like this, we can have what's called no correlation, which means that basically everything is all over the place. The more spread out this is, with something like this that I've drawn here, there's really no way to tell what the relationship is. This is an example of no correlation. We can't say that as one gets bigger, the other gets bigger. One gets bigger, the other gets smaller. The scatter is just too significant. These points are too all over the place for us to say that there's any real association between these two variables. Now, a couple more things we're just going to talk about for the concepts here is the idea of an independent and a dependent variable. Now, our independent variable this is on the horizontal axis. So this is the variable that just changes. This is actually the one that influences the other one. And we always label this on the horizontal axis. So if we have something like this, with this particular example, the height of a person is going to influence their arm span. So we've measured a bunch of heights and these just change normally. This sits on our x-axis. The dependent variable, however, let's write it down here. This one is going to be on the vertical axis. Now, this particular variable, as it states in the name, it is dependent on the other one. It depends on whatever my other variable is doing. So this is going to sit on our vertical axis, and from here, the arm span is dependent on the height. That is the thing that's changing as the height is increasing or decreasing. So these are the main key ideas when we want to use a bivariate scatterplot to discuss the association between variables. These key ideas we've talked about is, first of all, a direction of association. Is it positive or negative? This relates to our gradient. The strength of association, how much scatter is there in our scatter plot, or in other words, how linear is our scatter plot. The more linear it is, the more we can say that one variable influences the other. And finally, we've introduced these ideas of independent and dependent variables. The independent sits on our horizontal axis, the dependent will sit on the vertical.